Hi everyone, it's Kaswini here again. So yeah, in this video I will be guiding you or explaining the Cairo syntax or the StarkNet contract syntax, and also in this video we'll be understanding a couple of things in this Cairo in this smart contract, and also I'll be talking about the differences between Cairo's contract and Solidity smart contract. All right. So first of all, we have been talking about Cairo. So what is Cairo actually? All right. So let's start with that. So Cairo is a a language. It's a language that helps you to write provable smart contracts or provable programs, right? Yeah. So if you know about what the whole StarkNet and zk-rollups are, it's a way you prove that something is actually valid uh, without you revealing information about that thing you're trying to prove that is valid. So with Cairo, you can write provable contracts or provable programs, right? And also, there's a difference between uh, Cairo programs and StarkNet contracts. So the major difference between Cairo programs and StarkNet contract is that Cairo programs, they don't have uh, access to storage. They don't have access to storage. So you're basically writing smart contracts, but they don't have access to storage. But the StarkNet contracts basically run on the StarkNet virtual machine. And once you have access to the StarkNet virtual machine, you automatically have access to the storage and all of that. So these are some of the key things you need to understand between the differences between the Cairo program and the StarkNet contract. All right. That being said, let's take a look at the contract we have in front of us. So if you're been writing Solidity, or if you're a Solidity developer, you notice that there are some key differences between Solidity and Cairo, although there are some similarities as well, but with different syntax. All right. So first of all, we are going to look at what we have at line one. So line one is so the same way you have your pragma solidity on solidity, where you do pragma solidity and you put in your version. But on Cairo, what you just do here, you just do percentage this lang, and you're telling this guy that this is a StarkNet program. This is a StarkNet contract, right? So the VM will understand this file as a StarkNet contract. That's what you're trying to say here. Then line two, this is basically a way of this like making an import. So on in Solidity, you do something like import. You use quotes to pass in the URL of what you're importing, or the directory of the contract or what the library you're importing. So this is how you import in Cairo. So you do starkware.cairo.common.mat and import. So this imports uh, whatever you want to import. So this assert non-negative, this is basically used to check that to assert that a number is not a negative number. You understand? So it asserts non-negative. So this other import here is called hash built-in. So this hash built-in, we are going to see where we used it here. So this is basically used for hashing whenever you want to do anything that has to do with hashing in Cairo. You make use of hash built-in, right? So and here we are importing get caller address and get contract address. Now, so I'll be using Solidity as my reference point for explanation. So it's easier for you to understand it. So if you're watching this video and you don't know about Solidity, I'm pretty sorry, but I think I'll be using Solidity as a base point for referencing, so that it drives what I'm trying to say clearly, and people are able to understand what I'm trying to say. But if you haven't done Solidity before, I'll do my best to explain it the best way I can so that you understand this. So now this get caller address and get contract address, it's so the get caller address is it's used to get the address of the person calling a particular function in this contract, right? So like if your wallet is connected and you're performing a call to any of these functions, this get address is what returns the address of the person, the address of the caller, right? So for the Solidity folks, this is similar to your msg.sender. So in Solidity, you have a global variable called msg.sender that returns the address of the caller or anybody calling a particular function. So that is what this get caller address does as well. Then this get contract address, this gets the address of this contract, this current contract we are on. So this gets the address of this contract. That's what this get contract address does. So in Solidity, this is what we refer to as address this. So yeah, this is what we refer to as address this. So in Solidity, the get caller address is the msg.sender, while the get contract address is the address this. So this guy is for this guy, this msg.sender, and this get contract address is for this address this. So yeah, but here in Cairo, you have to import, for you to make use of this guy, you have to import it. So you import it, it's a syscall, so you import it to make use of it. All right, so that being said, let's move over to another thing that is different, like, okay, another area so that we need to understand. We need to understand what felt is in Cairo. So felt stands for field elements, right? So felt stands for field elements, and felt is it holds it's capable of holding 31 bytes. Its size is the size of a felt field element is 31 bytes, which is equal to 252 bits, right? All right. Now, in Cairo only have one data type, and this felt data type can hold integers, can hold unsigned integers, right? It can hold short strings. So they are called short strings. I'll explain why we call them short string. So we hold short strings, right? So felt felt is the only data type in Cairo. Unlike solidity where you have integers, unsigned integers, you have arrays, you have mapping, you have uh, bytes. So you have string, sorry, you have string, right? You have bool, and what else? You have address, right? So felt 2 can also hold address, right? So these are the data types in Solidity, and yeah, but in Cairo, felt is the only data type you have, and it can hold all these guys you see inside this bracket. And felt, the value felt can hold is 31 bytes, which is equivalent to 252 bits. All right. Now, the reason why I talked about short strings is because the the string felt can hold, it's only the string that the when converted, like the string that is between 0 to 252 bits. That's a string in which the size is 31 bytes. So anything that exceeds 31 byte size of string cannot be held in felt. Felt cannot hold that. You understand? So felt can only hold short string, but not a whole long text and all of that. All right. So that being said, everything you're doing in Cairo, every variable you're setting in Cairo is of a type of felt. That's why if we highlight this guy, you see that here we are expecting an address, felt is being returned, and here as well we are returning uh, an integer, like a number, because balances returns an integer or unsigned integer. So in Solidity, we make use of unsigned integer a lot. So this will be returning an unsigned integer, and felt here, felt is the data type. So with time, I'll get comfortable with referring to everything as felt. So balance, we are taking in felt, and we are returning felt as well. But coming from Solidity background, I know we are taking in an address here, and we are returning an unsigned integer here. You get? So you see, everything here is felt, 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 and all of that. So I believe with this, you should understand what field elements are, and all of that. So the field elements have a problem. So felt has a problem when it comes to division, but it's not something I want to cover in this video. So you have to do a lot. You have to read up about felt to understand that. But it has a problem when it comes to division. But there are libraries that there are libraries, already made libraries in Cairo, that helps you handle division when it comes to felt. And also, just like I said, that felt is of size 252 bits and 31 bytes. But you know, since Cairo is a language for writing provable programs, and StarkNet, as the case may be, it's a layer 2 scaling solution for Ethereum, which means since it's a zk-rollup, which means transactions from StarkNet are being bundled and rolled up to Ethereum, which is the layer 1 that StarkNet is dependent on. So there should be a way for everything to sync. And since Ethereum and Solidity make use of UIN 256, which is 256 bits and 32 byte size, so there should be a way for StarkNet to balance things up. So you can actually achieve 256 bits in Cairo, but to do that you make use of a struct. So you do something like so let me clear this guy up. You do something like struct here, and you call it uint 256, and you do this guy. So once you do this, so here you're going to do something like felt, right? And when you do felt, so when you do felt, sorry, so let's say you have a low here and you say felt, you say felt here, and you come here and say hi, and you also say felt, right? So this struct, so this struct, it's going to give you u in 256 because struct, the way struct works in Cairo, struct have size, and the size of a struct is the sum of the members of that struct, right? So but let me not confuse you more. We'll talk more about that in subsequent videos. Okay, so but for now let's proceed to understanding the contract we have in front of us. All right. So the next thing we are going to look at, we are going to look at what we call decorators. Yeah. So we have 1, 2, 3, 4, 5, 6. We have six, if I'm not mistaken. We have six decorators in Cairo. So the first decorator we have is the uh, storage variable. So I'm just going to name them. The second decorator we have is we have the view. We also have the external. The external. We have the constructor. Constructor. We have events. How many do we have here? 1, 2, 3, 4, 5. We also have one other one called L1 handler. L1 underscore handler. All right. So the reason why I want to explain this, so that before we move into this contract here, we should already have an idea of what is happening here, so we don't get confused. All right. So here, storage variable is it's synonymous to our state variables in Solidity. So anything you declare under storage variable, it's like you're declaring a variable. So the way this happens is you say storage variable and you do func, and what is the name of your variable. For instance, let's say I want to create a variable that stores uint. I'll say, and I want to call it uh, contract count. I'll just copy and call it contract count, right? And I'm gonna do this and I'll point it to this guy. So, and here I want to specify what is going to return, and I want it to return a number which is of type felt. Yep. And here we go. So this is how you declare a state variable in Cairo. It must be under this decorator storage var. So this variable now, what this variable will be holding, this variable will be holding it will be returning numbers. So that's basically what this variable will be returning. It's going to be returning numbers. Like I'll be saving numbers to this variable. But just like I said, everything in Cairo is felt. So yeah, with time we are going to get used to calling, okay, this variable will be storing felt, you get. But the reason why I'm calling number is so that you're able to understand what I want to save here, because by the time I say this variable will be holding felt and I'm saving number, and when I go to a variable that is meant to hold address, I also say this variable will be holding an address. I say this variable will be holding felt as well. So it gets confusing. You understand? It gets confusing. So the reason why we have decorators is because uh, everything in Cairo is being written the same way with this func keyword, the name and the rest of the part of the function or the variable. But the only way to differentiate them is using these decorators, these function decorators and all of that. I don't know if this makes sense. So this storage var decorator is used wherever you want to declare a variable, a state variable. You understand? I'm calling it state variable because yeah, in Solidity they are basically state variables. The variables that are declared outside the function, they are state variables. So they hold things that are stored to the blockchain and can be manipulated based on the logic. You can change them, you can update the storage and all of that. So that's the state variable, and they are permanently stored on the blockchain. Whatever you have here is permanently stored on the blockchain, unlike the local variables that you declare inside the function that are in memory and only lives while the function runs and all of that. So that being said, we are done with the storage var. So the next decorator we have here is the view decorator. Now the view decorator is used whenever you want to write a function that is basically reading from state. Like okay, in Solidity we have the view function. So the functions with the view the view what is it called again? So you know in Solidity we have something like external view. We have functions that updates the blockchain state, and we have function that reads from the blockchain state. So function with the view keyword in Solidity basically read from the blockchain state and all of that. So same thing is applicable here. Since everything in Solidity, everything in Cairo makes use of the func keyword, it will be hard to differentiate what this is doing from what the other is doing. So with this view decorator, you already know that okay, this this function is going to be reading from state and all of that. So anything you put inside this view decorator is basically telling Cairo that you want to read from the state. You want to read from the blockchain state. So for instance, let's say we want to read the balance, because here we're just declaring this variable. Let's say we want to read this contract count. We want to read it. So what we are going to do, we'll call this get contract. So okay, get contract count, right? So this get contract count, we are going to also do something like we point it to this, and it's going to be returning a felt, and we want it to return num, right? So going here, we are going to do this, and we are basically going to say uh, let uh, let num be equal to contract count dot read, right? And we are going to return num here, right? So if you look at this guy and you look at this guy, they are similar. So let num equals to contract account.read, which is this guy. So we are reading from this guy and we are returning whatever is here. This can be anything. We can say let new count equals to this. So we can return our new count here. So this is basically how to read from state and all of that. Now, there's something we need to also talk about, but that will be after explaining these decorators. So the next thing we will need to look at is this external decorator. So whenever you make use of external, now before I proceed, both view and external decorators are used for functions. So this is used for functions that are reading from state. This is used for functions that are writing to state. There's no internal or private function in Cairo, just the same way you have in Solidity, where you have private functions, you can't view them outside. You can see both this and you can see this. They are both you can see them like you can interact with them from outside the contract. So there's no private or internal in Cairo. So that being said, now let's look at external functions. So external functions are used to write to the blockchain state, right? So let me do this func increase what is it called, contract count. So now this is going to increase this count, and sorry, so what this is basically going to do is going to take this okay, first of all, let's do this. Let's say we need to first get the previous count. When we get the previous count, then we increase it by 1 and update the state. So the first thing we need to do, let's just get this guy. So I'll just copy this guy. So this should be, let me call this count here and return count here. So what this will do basically is I'll remove this guy here. So first of all, I'm saying let count be equals to, I'm reading the current balance. Then I'll now say Let's uh, increased count is equal to count plus 1, right? Then I'll now say contract count dot write this guy. Then I'll return. So every function in Cairo must make use of this return guy, else it will throw an error, just the same way we have it here. So you must make use of that return guy. So now this is how you update a state in Cairo. So you see, first of all, we got the current count, we increase it by 1, and then we now update the state. So contract count dot write. Here to read, we did contract count dot read. That's what we did here, contract count dot read. And to write to it, that's to update to it, do contract count dot write. Then we pass in what we want to write to that state, and we do this return. So you see, this is the syntax is a bit different. Now, what if maybe you want to receive, you want to take in a variable? So if you want to take in a variable, what you do, you now say, let's say you want to take in a variable, say amount, or you want to say new number. You ensure that you specify the type of field here. So what you're going to do here, you say you read from this contract, then the increased contract will now be this plus new number, and then you do contract dot write the increased count. So this is where you're performing your maths and all of that. Are we good? So so for the constructor, you make just the same way you have constructor in Solidity, where you specify a function that is called once when the contract is being deployed. So you also have that in Cairo, but it's done under the constructor decorator. And yeah, and also for events, you know, you have events. So whenever you update a blockchain state and you want to emit an event, so you make use of this event decorator. While this L1 handler, the L1 handler, it's used whenever you want to it's used when you want to handle a transaction that is coming from an L1 blockchain like Ethereum. So you make use of this L1 handler and all of that. So that being said, now there's something else we need to talk about, and they're called implicit arguments. So now, if you look at these functions here, you see that we have some arguments here before. So after you write the name of your function, you have this argument here and all of that. So they are called implicit arguments. Now, the reason why I didn't use them here is because I didn't want to confuse you. But now we are going to talk about them. So implicit arguments, they are like, so Cairo it's a language that is in between, it's like a low level programming language. It's not really high level like Solidity. So it's closer to your machine. And languages like this, everything has to be explicitly done, like they have to be explicitly spelled out. You understand? So Now, implicit arguments they help functions in Cairo perform some necessary manipulations. You understand? They help functions in Cairo perform necessary some basic manipulations. So we are going to look at this implicit argument, and I'll explain each and every one of them. So the first guy we are going to look at here is the what is it called, the system call pointer. So this is it. Let me just do something here. So I'll call them implicit arguments, and here I'll say one, we have the system call pointer, and two, we have the Pedersen pointer, Pedersen pointer, and three, we have the range check pointer. All right. So this syscall pointer, the syscall pointer, this is used in functions where you are performing a system call. All right. So now this system call in Cairo refers to any any um, any call or any function that requires you to make a call to the system. What's the best way to explain this thing? For instance, this get contract address, you're performing a system call, right? And this get contract address is also performing a system call to get the address, or this is performing a system call to get the address of the caller of a particular function, and this is performing a system call to get the address of this contract, right? And also note that this dot read you used here is a system call because you're trying to read from state. You're trying to read from the system state. And dot write also is a system call because you're trying to write to state, right? And that being said, you have to use this system call pointer in this contract count. So, and to use that, you don't put the argument inside this bracket. You put it inside something like this, and you say is syscall. So you see it's already suggesting it here, syscall underscore ptr, and this is going to be this guy, felt guy, and you make use of this star. So this is how you make use of this pointer. So, and this has to be in all your functions, both the read and the get. I think it's a must for it to be, because you're either performing, if you're using this here, if this is a view function, you're reading from state, and if you're reading from state, you're making use of this dot read, which is a system call. So you must use this guy here. And this guy is an external function, which is obviously writing to state, and this is also a system call, which means you must use this guy too here. So let me just paste it here. So we have this guy here, right? Now, this is for system call. Now let's look at the Pedersen pointer. So The pedestal pointer is usually used for hashing. Is usually used for hashing, right? Now, I know you might and you have to use the pedestal pointer in both your view function and your external function. Now, your question will be why? Since we are not performing any hashing in these two functions, we are not doing any hashing here. The same way, just like a solidity where you do the KCAC 256 and all of that, we are not doing any hashing here. So why are we gonna be using this pedestal pointer here? Since it's okay, let me just put this guy here. This pointer is usually used for um, for or usually used in hashing. Yeah. So now, but I want you to understand something. The way things are being stored in blockchain involves hashing. So I think it will really make more sense if anyone taking a Cairo is coming from a solidity background, because a lot of things are similar. So if maybe you've actually understood solidity or maybe Rust, a lot of things might not be difficult for you to understand. So in solidity, when you want to store certain things to the block, to the EVM, for instance, let's say the way mapping is being stored. Okay, let me do this. The way mapping, the EVM stores the way values of mapping is being stored. Like if the EVM wants to assign a slot for um, a mapping, okay, it's basically the KECAC, the KECAC, the KECAC hash. That's the KECAC 256 of the slot. Like, so if the mapping is declared at state at the first slot, so usually the KECAC 256 of the slot number, right? The slot number concatenated with, sorry, the KECAC 256 of the key of that mapping concatenated with the slot number. So let me do this like this. So now, whenever you make use of KECAC 256 in Solidity, this is a hashing, right? This you're performing a hashing, and now the EVM uses the number that is derived from this guy to as a slot number to where the value of this mapping will be stored, right? To where the value of this mapping will be stored. But for things like uint, it basically use the actual slot, or the actual slot of where the variable is declared, to store the value of that uint, or the value of whatever is saved to that uint. But for mapping, it uses the KECAC 256 of the key of that mapping and the slot number where that mapping is declared to store the value. Now, same thing is applicable here in Cairo. So the reason why we use this pedestal pointer is because for this for you to read or write to the blockchain, a hashing is done, like some kind of hashing is done. So the hashing is done to actually know the particular slot to read from, and hashing is also done when you're writing to the StarkNet VM to actually know to actually define the slot where what you're writing is being written to and all of that. So that is why we also need the Pedersen pointer. So I don't know if that makes sense. So it is written as Pedersen pointer, and that is where we make use of this guy we imported here, this hash built-in, right? Okay, so let me see if we are good. All right, okay, has an asterisk in front of it as well. All right, and we are good. Let me take this guy back here. So to this other function. So now you now know that for every function you write in Cairo, you must make use of the syscall pointer and the Pedersen pointer, right? Now there's one other pointer we have to look at, and that is the range check pointer, right? So the range check pointer is basically used, this is used for comparing numbers, right? So yeah, it's used for comparing numbers. And you might also ask, what if why, okay, and for this range check pointer, you also need it in all your functions, whether view or external, right? So let me pass it here as well. So you might ask the question, why are we using range check pointer when we are not doing any number comparison? But now you know that Cairo deals with only felt, and felt it's a number. You understand? Felt is a number. So for you to read and write to state, there is some kind of comparison that is being done under the hood. So if you don't use the range check pointer or any of this pointer, your function will fail. Your function will run, you will run into errors. So that is the reason why we make use of this implicit argument. That is what the main reason why we make use of implicit arguments. So I don't know if I've been able to explain this better, or if I've been able to confuse you the more. So if I confused you, please ask your questions in the comment section, and also before we go, let me also tell you to, for you to get more of content like this, you can also subscribe to my channel and turn on the notification bell, so that whenever I post new videos, you'll be the first to get notified and all of that. And if you find this video helpful and interesting, like if this has helped you to learn something new, then you can click the like button, so you help other people that are to the way the YouTube algorithm works, to help other people see this content and all of that. So this being said, then let's this video is getting long. I don't want it to be very long. I would have wanted us to take a look at this contract, the contract we have here. So so I believe we have been able to understand most of all these what's it called, storage var, view, external, constructor, event, L1 handler, and we now know what these guys are doing here. So the reason why we are not making use of any of these inside this guy, this storage var, is because this is basically a variable. It's not a function that is, it's not a function, it's just a variable. It's not doing any of this guy, right? So yeah, that's why we don't have this implicit argument on our storage variable, because storage variable is just a variable that yeah, a variable that holds something. It's not performing any action. It's neither reading from state nor writing to state and all of that. So yeah. So okay. So let's take a look at what we have here. So first of all, we have this storage variable. Now, another thing you need to know is that in mapping is kind of easier in Cairo. So in Cairo, you can this guy now, this is a state variable that holds that returns balances of a particular address, right? So normally in Solidity, you will just write a mapping and map address to uint and give it a name, right? But here we perform the mapping right inside this guy. So this balance, this is the key. The key here account is like in okay, let me use this guy. So see something like mapping, right? You do something like address. So address is the key and returns uint 256 and you call it balances, right? So you know this mapping, whenever you pass in an address, it returns the balance of this address. Same thing is what is happening here. So your note that you're declaring a state variable, but this variable is a mapping. So it's taking in an address as the key and it's returning in the balance. That's a uint, but they are both of type felt. Just like I said in Cairo, everything is felt, field element, and all of that. So the reason why I'm using these mappings is to help you understand. So once you understand what this guy is doing, you already know what this guy is doing. You get. So that is what's happening here. So this guy, it's a mapping. It's a storage var, but it's a mapping. So it takes in an address and returns the balance of this address, right? So first of all, we have an external function that updates this balance. So you see, it's taking, this is the func keyword. These are the implicit arguments, and it's taking in an amount here of type felt. So you want to pass in an amount that you're going to use to increase this guy. So first of all, we want to get the caller, the person calling this guy. So we already have we already imported our get caller address here. So what we are doing, we are saying let caller be equals to get caller address. So you see I added a comment here, msg sender. So for the Solidity folks, you know that okay, this is like your msg sender. Now this guy now with attributes, so this is how you do your require statements in Cairo. So if this was in Solidity, you do something like let me write this. You do something like require. So I'm trying to use Solidity to explain this so that you don't get confused. You do something like require that that amount, right, is so here you want to ensure that this is a positive number, all of that. So in Solidity, once you make use of uint, you already know that this is not going to have whether negative sign or positive sign in front of it, because uint stands for unsigned integer. So what you basically check in Solidity is require that amount is greater than 0. Then you now do something like amount must be positive, or amount must be more than 0 and something like that. So this is what you do in Solidity, your require statement. But in Cairo, you say with attribute error message, amount must be positive, you got this amount. then you now assert non-negative. So this assert non-negatives, here I added a comment, say assert non-negative ensures that the amount passed is not negative, else the above message is thrown. Think of this like require statement in solidity. You get this? So that is what is happening on this line. You get? So that's why we have the assert non-negative. So if this guy is passed, then here we now say let previous balance be equal to, so we want to get the previous balance. So you know this is our balance, we want to update this balance. So we now have to say let previous balance be equal to balance dot read. You pass in the key, which is the address of this caller we got here. You understand? So this other part where we made use of read, we only read from it because there's no key, we just read. But here we are passing in the key, which is the address. So it's going to return the balance, it's going to save the current balance of this caller to this variable. Then now new balance is now equal to caller previous balance plus the amount we are passing here. So once you do this, you have gotten your new balance. Then to update the state, you now say balance dot write the key. So you want to write to this person's balance and you pass in your new balance. So when writing to when writing to a state, when writing to state, writing to mapping state, comma, key comes first followed by the new value. Yeah, so when writing to a mapping state, so you know that variable is a mapping, so the key comes first followed by the value. So this is it. So you put in the key, which is the address of the caller, followed by the value, then you perform your return. So here we are just getting the balance. So this balance is just setting this guy, and you say let result equals to balance the read and the account of. So we made it dynamic so that you can pass in the address of the person you want to read their balance, or you can either make this more dynamic by not passing this address. You can either do something like this. You can come here and update this like this and remove this guy here. Then you make use of this guy here. So this way, this function will automatically get the address of the person calling it and it will return the balance. But here we have the previous way it was is we are making it open for users to pass in the address they want to check the balance. That's why we are receiving this guy here, right? Then just like I said, the constructor. So this is a constructor. It's also making use of the implicit argument because constructor is a function as well that can read or write from state. So this guy is setting the contract balance to 1000. So once you're deploying this contract, the contract balance, this contract, the balance will be increased to 1000. Now, if you have noticed, there's one thing I want to point before I end this video. If you have noticed, you'll see that here, when we are doing let here, we passed this guy inside parenthesis, inside this bracket. But when we are doing let here, we didn't pass this guy inside parenthesis. Now in Cairo, whenever you're saving, whenever you want to assign a value to a variable, if what you're assigning to that variable is a function, like it's performing a system call, you have to declare your variable like this. You have to pass that variable inside parentheses like this. But if what you want to save to that variable is not performing any system call, it's just something like this plus this, you understand? you can declare it like this without passing it inside parentheses. So if you take a look at this guy, you see that here I'm performing a system call. So I say count is equals to contract.count. I'm calling this read function, right? So and here also I'm doing the same guy. You understand? So but here I'm just doing count plus new this guy. So I'm not performing any function call here. So that's why I didn't put this guy inside parentheses and all of that. So and you see here after every function there must be a return keyword. This is an external function. This is write to state, but you must also make use of return. But here the return doesn't have anything. But when you're reading from state, the return has something. That's what you want to return for your users to see. So that being said, this video is already 1 hour and I don't want it to be more than an hour. So thank you very much. I hope I've been able to help you understand the Cairo syntax. So stay tuned, subscribe to the channel. I'll bring you more content to help you understand Cairo. As I learn, I'll also be explaining what I understand. So we move along. Thank you very much and bye for now.